Okay, now we're going to talk about the relational algebra and relational calculus. In part 1, we're going to talk about the relational algebra first, and then we're going to continue to the part 2 about the relational algebra, especially for joint operations and relational calculus. The relational algebra and the relational calculus is the basis for relational language, according to Code in 1971. Relational algebra is a procedural query language. It gives a step-by-step process to obtain the result of the query. It uses operators to perform queries. To explain procedural, so SQL is declarative, which means that you tell the DBMS what you want, but not how is it to be calculated. A C++ or Java program is a procedural, which means that you have to state step by step exactly how the results should be calculated. So, relational algebra is a procedural query language, which means we can see the step by step of the process to get the result. Relational algebra, actually, it's similar to normal algebra, as in when we calculate 2 plus 3 times x minus y, except we use relations as values instead of numbers, and the operations and operators are different. Relational algebra is not used as a query language in actual DBMS, but we use SQL instead. Why do we need to learn about relational algebra? Is to understand query execution and optimization in a relational DBMS. Relational algebra is more procedural than SQL. Actually, relational algebra is mathematical expression. Okay, so in the relational algebra, it basically taken from the set theories. We do have something like union, subset, superset, intersection, Cartesian product, set difference, element, no order among the elements, proper subset with fewer elements. This whole concept from the set theories, we apply them in relational algebra. This is a general view of the relational algebra. We have selections, projections, union, set difference, intersections, Cartesian product, join, division, aggregate, and grouping. For the first part, we're going to talk about these 6: selection, projection, union, set difference, intersection, and Cartesian product. And then again, continue to the second part for join, division, aggregate, and grouping. So this is the illustration how we perform those 6 important operations in relational algebra. For selection, we select the based on the rows, and with the projection, we select based on the column. Cartesian product, which means we combine between first relation and the second relations. In union, we combine between 2 relations. Intersections, we take only the middle part of both of the relations, which means the intersection part. In the set difference, we only use the first part of these combined relations. For example, R minus S, so we take only the outer part of the relations, combination of the relations. So this is the illustration of natural join, semi-join, left outer join, divisions, and some example of divisions. In natural join, we do the join between 2 tables, and then we come up with the column from those two tables, A, B, and C. In semi-join A and B, we do have similar to natural join, but we take only the first relation structures. Left outer join, we also include the record that is not matched with the other relation. How about the division? Division is something like this. R divided by S. And then what we take is the R part but not included the remainder and not included the S. So the example of division something like this. If we have set of V and set of W, V divided by W is equal only the part of the V minus part of the W, and we ignore the rest. Okay, to mention the selection or restrictions in relational algebra, we use this kind of symbol. And then we also need to specify what predicates, and we also need to specify what relations. Selection works on a single relation R and defines a relation that contains only those tuples or rows of R that satisfy the specified condition or predicate. For example, we want to list all staff with a salary greater than £10,000. So we draw something like this. Select salary more than 1,000 from staff. So the result table is like this. How about the projection? Projection works on a single relation R and defines a relation that contains a vertical subset of R, extracting the values of specified attributes and eliminating duplicates. So with this symbol, projection, we mention what column we want to show and then what relation we want to take. This is some example how to use projection. Suppose we want to produce a list of salaries for all staff showing only staff number, first name, last name, and salary details. We do something like this. Projection on staff number, F name, L name, salary from staff. The union R union S means the union of two relations R and S defines a relation that contains all tuples of R or S or both R and S. So actually, we just want to combine both relations. For example, we want to list all cities where there is either a branch office or a property for rent. So we project city from branch, union, project city from property for rent. How about the set difference, R minus S? It defines a relation consisting of the tuples that are in relation R but not in S. So we take only the relation part of the relation R which are not the same as S. So, for example, we want to list all cities where there is a branch office but no properties for rent. Project city from branch minus projection of city from property for rents. So the result is city Bristol. Intersections is working the same way like set intersections. R intersection S defines a relation consisting in the set of all tuples that are in both R and S. For example, we want to list all cities where there is both a branch office and at least one property for rent. We project city from branch intersection with projection of city from property for rent. The Cartesian product R Cartesian product with S or R cross S defines a relation that is the concatenation of every tuple of relation R with every tuple of relation S. So, for example, we have set of P and set of Q. And then the Cartesian product of P cross Q is A1, A2, A3, B1, B2, and B3. For example, we want to list the names and comments of all clients who have viewed a property for rent. So we do something like this. Projection on client number, first name and last name from client intersection with projection of client number, property number, and comment from viewing. The result table is shown in the figure below. Thank you.